Hello everyone, GZ Tech here, back with another how-to video. In this video, we're going to be covering climate control basics and calculating your heat loss, as well as using a piece of software from Rittal called Therm that you can use to accurately size these climate control products like AC units, fans, etc. for your electrical enclosures based off of that heat loss. Therm allows you to accurately calculate the climate control products that should go in your enclosure or externally to the enclosure to cool the inside temperatures or heat them depending on which time of the month, so that your electronics inside can do their job at the right temperatures and not become overheated or too cold and freeze up on you during the winter months. To download Rittal's Therm software to calculate heat loss and size your climate control products, you first want to go to rittal.com, and once you're on that web page, go to the left-hand side and click on Configuration. Once you're on the Configuration page, scroll down to Climate Control and click on Calculate your climate control requirements. You'll see Start Calculations, which will launch the online version of Therm, or download Therm offline, so you can actually download it onto your computer for calculations in the field, for instance. So now we've launched the online version, which we'll use for this video, of Therm. Once you get to the page for the Therm software, it will be in German by default, so we want to go to this drop down here first. And then after that, if you want to create an account, that is how you will get into the software. For instance, I registered myself. Then after that, you can log in. And now we are into the Rittal Therm software. Before we get started doing our heat loss calculations, I did want to mention a couple things at the top. If you want to start a new project, you can hit this Start button here, which will bring you to the default screen to start a project. There is a lot of other helpful things on here, like humidity calculations, efficiency calculators, etc. Under the Options tab is where you can switch from Standard International or Metric, or you can work in Anglo-Saxon, which is Imperial or Inches. So that's where you can kind of switch the software between what you want to work in. Heat loss is where you can load in a bunch of components from manufacturers of your choice and the heat loss calculations for those devices. And then that's pretty much all you need to know about the top portion of this web page. So now we'll get started by creating our first project. To start a new project, you want to select the first bullet point here. There is chiller and IT cooling configurators as well, but for the standard industrial applications, this is the option you'll choose to start a new project. It will bring you to another screen. You can start editing your existing projects as well, because this website does save your old projects. But for now, we're just going to create a new project, and do not select this checkbox. I was advised by Rittal not to do so when you're starting your first project. Now we are in the main portion of the Therm software, and this is just a project page where you can actually rename your project. So I will call it Airline Demo. You can save your project, and a good thing to know is this website will save your projects along the way as you move through different tabs. So if you want to come back and edit your project later, it will be stored on a server held by Rittal somewhere. So I'm going to save my project there as Airline Demo. On the bottom of this page, you want to put in the max external temperature to the enclosure and the max internal temperature inside the enclosure. And the max external temperature is the ambient conditions outside of the enclosure. This doesn't necessarily mean outside of the whole facility, but outside of the enclosure and where it's located. And you want to estimate this to be the worst case scenario temperature that your application will experience, so that the software can take that into consideration when guiding you to a climate control product. The internal temperature is what you want the internal temperature of the enclosure to be based off the components inside and what their temperature ranges are. So for this example, I will bring up my Word document with those parameters already set, but just wanted to explain those temperatures and what they mean. For this example,
we have a desired enclosure temperature inside to be 35 degrees Celsius and the max ambient or external temperature to the enclosure to be 40 degrees Celsius. The power is 230 volts at 60 Hertz. So I'm going to go back to my software and make sure everything's inputted exactly how I want it. So I do have external temperature 40 degrees Celsius, internal temperature 35. My voltage should be 230 volts at 60 Hertz according to this example. So we're good to go there, and we can move to the next portion of this software. One quick comment I wanted to make about the software is this software is for heating and cooling applications. So if you put in a negative temperature, for instance, where you need to use a heater to get the temperature up, the software is smart enough to realize that, and it will guide you to a heating solution. So just wanted to make everybody aware that this is for heating and cooling applications. The next portion of the Therm software is the Enclosure Selection, where you'll add in the enclosures you're using and what location style they are in your production facility. If you use the drop down here, you'll see all the different Rittal enclosures that are offered globally. You won't see the WM series or Junction Box JB series, for instance, because those are specific to the United States. So in that instance, you can use special sizes and directly input the width, height, and depth of those enclosures. I also wanted to mention this software can be used with anybody's enclosure. So if you have a Hammond, Saginaw, other enclosure lines, you can use this special sizes as well, and then directly input these different characteristics of the enclosure. I did want to mention the K factor, which is the heat coefficient, which is the transfer rate of heat into or out of the enclosure through the certain material the enclosure is made of. So if you are unsure about the K factor, you can look up that online for certain materials, or you can just go to another Rittal box that you know is made of stainless or carbon steel, for instance, and copy that K factor into this little box here. So that's a good way to have a general sense of your K factor. And then you can add in, if you have any divider panels in the cabinet, for instance, you definitely want to document that, which will affect the cooling of the enclosure itself. The bottom portion of the enclosure selection portion of the software is where you'll dictate how the enclosure is sitting in a facility, and if there's any walls behind the enclosure, if they're bayed together, what location that enclosure is bayed in the suite of enclosures, for instance, and if there's any walls or roofs around the bayed or non-bayed enclosures. So we'll go through these examples as we go through our application, but just wanted to reference what those meant as well. So back to our application example, we do have 4 bayed enclosures that are freestanding in a room, not next to a wall or with a roof over top. So I'm going to start adding these enclosures in, which are the TS8 enclosures. One thing to note in this application, I did not use different size enclosures as far as the widths. I just used the same enclosure, so your heat loss calculations might be a little bit different from mine. So I'm going to go back to my software. I am going to hit the drop down because this is a Rittal enclosure and go to the TS section. Once I am there, I can individually pick out the part number, which is 8606500, and this is the first enclosure in a suite of bayed enclosures freestanding. So I'm going to select this option 3. I am going to save enclosure. I do want to add heat loss. So in terms of adding heat loss, there's 3 different ways to add in heat loss in Therm. The first is if the heat loss is given the total heat loss of all components inside the enclosure, and you can put that directly into this box in wattage and you're done. However, it's not always that easy, so there are other ways to do so. The measured temperature tab is the second way to calculate your heat loss. If you don't know any of the electrical components inside of the enclosure and you don't have a schematic to get those components. So basically what this is doing here is you're inputting your ambient or external temperature to the enclosure, so you can measure that and input that there. you want to measure the internal temperature inside the enclosure, especially while the components are running, and put that there. And then after you accept that, it will use that delta T calculation along with the enclosure you already put in and the material that it's made of to calculate your heat loss. So this is a really good and most popular method of calculating heat loss if you don't know all the components or heat loss calculations already to get that heat loss calculation. The third way to calculate your heat loss is to actually add in all of the different components inside the enclosure. A lot of these are preloaded in the software if you're using Rockwell, Siemens, Phoenix Contact, for instance, or you can add them in yourself by using the General tab. So once you select General, you can select what type of component it is and then add in a few parameters. And then after you add in a bunch of components that are inside your enclosure, it will calculate the heat loss. So we'll walk through this in our application example, but those are the 3 ways to input heat loss into the software. So back to my application example, for enclosure 1 to finish that out, they did give us the heat loss. So I will go back to the software. I already inputted 100 watts and we are done with the first enclosure. Now I want to add a second enclosure, which is also an enclosure within a suite, but it is freestanding. So I'm going to save that. I'm actually going to add the same TS8 enclosure, which is that same part number. So I'll save the enclosure. I do want to add heat loss this time. And back to my application example here, the enclosure 2 has a couple of different components in it, and it tells you what those are, but not a manufacturer's name. So I'll go back to the software. I will go to the select device list because they did give us what type of devices those are. So I'm going to go to General because I don't know the manufacturers. I am going to add in a converter. The application example says it is 15 kVA, which I'll add in. And then you can simply add that device to your list. And it does give me heat loss already, which is very nice. So I'm going to continue adding all these devices in here for my second enclosure. Now I have all my devices loaded in with the correct quantities. I did want to point your attention to this factor here, which is correlating to how much these devices are running in terms of 0 to 100%. So I always like to keep that at 100% to almost overestimate the worst case scenario so that we can properly size the AC unit so that when everything's running 100%, it's still doing its job when cooling the enclosure. So I am going to hit accept. And now we have our second enclosure loaded in with the correlating heat loss. Back to the application example, I can add in the third and fourth TS8 enclosure. They give me my heat loss, so I'm going to add those in now. So now that I have all 4 enclosures inputted into the software in the correct positions as well. So this is my first one. These 2 are in the middle, and then this is the last one in the suite or bayed enclosure suite. I can click on baying so that I can bay these enclosures together. So right now they're all separated. If I hit the plus, it will bay those enclosures together. So I will do that for all the enclosures. And now we have the enclosure treated as one large enclosure because they are bayed together. So I'm going to close that now and continue to move on in the Therm software. Now that we've properly bayed the enclosures together, I can move on to the next step, which is the calculations page. And this gives me a lot of the overall calculations to the whole enclosure design. So you'll notice there is an installed heat loss, which is coming from the components, but the total heat loss takes into the environmental impacts as well, including that external temperature around the enclosure, which does affect things. So that is your total heat loss. And down here, you'll see that air-to-air or fan climate solutions are not possible because of the differential in heat. Fans or air-to-air heat exchangers cannot get you there in terms of the internal temperature that you would like. So to get to the cooling solution that is recommended for this application, you would hit the plus here, which will bring up those Rittal cooling options. The first one's always going to be the closest to what you should use, but they do give you larger options as well, even including the Blue E Plus, which is extremely energy efficient. So that might be something you want to mention to customers or just to yourself if you are using this software as an end user. You can change the mounting type of the AC units, whether it's a wall or roof mount, for instance. Maybe you need different ratings or different types of air conditioners, like NEMA 4X rating, stainless steel, etc. You can get all that information in this. So if you do select an air conditioner as well, you can get a performance diagram, schematic, for instance. If you want to see the cooling schematic on the air conditioner. And then finally, you can, if you click on this, get all the technical information as well. So this is how you would select what AC unit you'd like. So I will accept that first Blue E unit. And you'll see that Blue E, actually they're recommending 2 of them given the heat loss and what temperature you're trying to get to internally. And then you can move on to the next tab, which is the accessories, if you want to add in filter mats, door switches, and other accessories that go along with your cooling unit. You can add in the quantity that you want here. So filter mats are typically not shipped with the AC units because every environment's different and there are different type of filter mats per different environment. So I'm going to add in a standard filter mat and a door switch here, just quantity 1. And that will update here, 1 by 1 actually. And then we can continue moving on to our summary page where we can actually export this full calculation and all the accessories and cooling units picked. Where we want to, if we want to print it out, you can send it to a PDF or text, and text will actually send it to a Word document if you wanted to edit it. So that is the Therm software in a nutshell. Really powerful tool for calculating your heat loss if you don't know all your components, as well as selecting those climate control solutions that are perfect for your electrical enclosure.
If you have any questions around heat loss calculations, sizing, climate control products for your electrical enclosures, or just general climate control concerns, feel free to reach out directly to me, or you can visit our Airline website where you can not only shop for climate control products, or go to our Rittal Climate Control Services page where you can fill out information to let us know if you need help with repairs, maintenance, or even energy efficiency savings in your operational plan.